Welcome, everybody. This is Drew Borders here. On behalf of the NTMA Tech team, we'd like to thank you for your participation today in our discussion, Be Cool to Your Tools. The discussion will be hosted by Mr. Randy Templin, who has over 26 years of metalworking experience at Blaser, and also will be able to introduce himself and his credentials as we head on. So Randy, I turn this over to you, and look forward to your presentation.
Thank you very much, Drew, and thank you everyone for the opportunity and for attending today. The title, Be Cool to Your Tools, so we'll play on words there. It actually is a line of cutting fluids we offer called Be Cool. I thought it was fitting for the name of the title for today. So, a little bit about me. I've been at Blaser since 1994. Drew and I started actually the same year. Had various roles in applications engineering, sales management, product management. I'm currently the technical director for the Americas for Blaser Swisslube. We're based out of New York with the headquarters in Switzerland. I do work from my COVID cave here in Arizona. Usually do a lot of traveling. With this year, it's been cooped up like most people. I do have a certification from the STLE as a certified metalworking fluid specialist. And for those of you who do not know, STLE is the Society of Tribologists and Lubrication Engineers, and they do offer the certification program for metalworking fluid specialists. For today, the content put together is really just a brief overview about Blaser Swisslube for those of you who aren't aware of who we are, what we do. We'll get into some basics of metalworking fluids that are often overlooked but so important to know about. Condition monitoring and influence on performance. This is a big one, and hopefully we can dig deeper into some of those subjects. Some information on high pressure coolant systems, which pretty much in today's society shops, most everyone has at least one machine with high pressure. And we'll get into just a case study to show you really when a coolant becomes a liquid tool and show you in action what that can mean. And we should have plenty of time at the end, hopefully, for some good question and answer and discussions. So a little bit about Blaser Swisslube. We are, as the name indicates, we are a Swiss company. You can see our factory and headquarters here in Switzerland, the Emmental. There's a river running right through, pretty much next to our property. We're pretty close to where the famous Swiss cheese is made in the Emmental. And a hobby of the company is hot air ballooning. So we're very, very close looking at the environment around us. We're very aware of it. It's always on our minds, and it's also part of our development of products, keeping that environmental and people aspect high in mind. We were founded in 1936 by Willy Blaser, who started off, his very first product was a waterproof shoe polish that he went door to door and sold to Swiss farmers. To the company it's become today, in large part because of his son Peter, who started the metalworking division, and now we're run by Mark Blaser as our CEO, Peter's son. Still a family-owned company. We're up to over 600 people worldwide. Half of those employees are in Switzerland, where a large workforce in R&D is employed in particular. Our product lines you may know us by are Blaser Cut, or one of our founding product lines, Be Cool, Vasco, cutting oils like Vasconil, Grindex, and things like this, Blaser Grind. Our focus products, especially in the Americas, are cutting and grinding. It's really our blinders are on to the other things. We're really focused on cutting and grinding fluids and technologies, although we're now launching, with a lot of Drew's work, a line of EDM oil called Blaser Spark. But these are the main lines you may know us by here in the Americas. The liquid tool, we coined this phrase a number of years ago, and really what it's about is using the right fluid correctly. Really makes it a liquid tool to give you the full benefits of why you use cutting fluids in the first place. And the lower left picture there shows our tech center in Switzerland, where We develop products not only in the lab, but also on real machines, doing real live test cutting on tough materials, and really get a good feeling for what applications are best suited for a particular product. We support our customers with laboratory support and monitoring, especially those large central systems where it's critical that they're monitored properly to ensure a stable process. So these things together really make a full liquid tool. And the benefits of that, really bottom line, is increasing your competitiveness. I know a few of our people, Carsten and I's boss, for example, Carsten gave a presentation to the NTMA, and the theme of that presentation was competitiveness. And that's really the benefits you get out of a real liquid tool. That's machining quality, that's making better parts with less scrap for lower cost. That's increasing the tool life, for example, or decreasing machining times and being more productive, less stoppage of the machine due to coolant problems, your employees with better attitudes because the fluid is not giving them dermatitis and not stinking terribly. So these things are all part of the liquid tool benefit, and really bottom line, making you more competitive. So that's kind of a summary of who we are and what our aim is. And so now we'll get into the contents and to the basics of metalworking fluids. Starting off with, why we use cutting fluids in the first place. There's primary functions, and then there's secondary requirements, which can vary from customer to customer. But pretty much everyone is using a cutting fluid because it helps reduce the friction in the process. If you didn't need to reduce the friction in the cutting or grinding process, you could just use water to remove the heat and flush the chips. So really, you're buying that metalworking fluid to reduce friction. And again, if you just wanted to remove the heat and flush chips, we wouldn't be in business. Blaser would be selling something else. And those secondary requirements, though, on that cutting fluid are, corrosion protection of the parts in the process, being able to use in the high pressure system, for example, being compatible with all the different materials you're cutting, whether it's plastics or if it's high temp alloys or aluminum or copper, for example. People want easy to use, low maintenance products that are also compliant health and safety wise with the local and state country regulations. In addition, each of you end users have your own health and safety tests, right? You have operators touch, feel it, smell it. Is it okay? Do they have an irritation or what have you? So all these things need to be taken care of before you move forward with the cutting fluid, not to mention the life of it in the sun. There's one exception to this, and as far as the primary tasks of metalworking fluid, and there's one application and one type of fluid that focuses really only on the first, reducing friction. So I'll give you a time to think of what that could be. But what I'm referring to here is minimum quantity lubrication, MQL. And the only thing we're doing there is you're putting a tiny bit of oil in the process in the form of a droplet, a small mist. You can't even see it, and it's only there to reduce friction. It's not removing heat, and it's not flushing chips. So that's the one exception where you don't have those other primary tasks of the metalworking fluid. So now that we know the tasks are, what's in that drum? And what type of fluid is out there? There's all these different technologies, classifications of metalworking fluids. If you look at the bottom, I show pictures here, and the one reason why I show these pictures, because you don't see much of a difference, do you, between a quote soluble oil or a semi-synthetic or even an ester-based fluid here. They all look potentially the same. And even the full synthetic looks just like oil, because pure water looks clear, colorless, right? And the full synthetic, unless it has a dye in it, is going to look just like water. And a neat oil, think about kerosene there, or just a pure base oil, white oil, clear, colorless oil. So with cutting oils, you can get that as well, totally clear, colorless cutting oils. You can't see the performance from any of these things or know what they are. It's in the drum. So it's difficult to just take a look at the fluid and determine what type of fluid it is. But we're talking soluble oils here. We're talking about higher mineral oil containing products. If you look in the left column here, with a small amount of water and some other additives, for example, the emulsifier to get the oil to go into emulsion into the water, performance additives, corrosion inhibitors, defoamers, and a host of other additives that may go into formulation. There are rather simple formulas out there, maybe less than 10 ingredients. Then there's very complicated formulas, typically in the semi-synthetic range, that have maybe over 20 ingredients in that metalworking fluid. And that varies a lot here in the semi-synthetics. The mineral oil content can be as low as 3 or 5%, or as high as 25, 30%. So it really varies greatly. There's no pure definition that's everyone is using to describe a semi-synthetic. It's become a bit of a marketing term. There's no real concrete description or box that you would put a semi-synthetic into. But typically over 20% water in the drum, and 10 to 25% typically of mineral oil content, maybe lower or higher. Then your ester-based cutting fluids, you can have them totally neat oils that are ester-based, or emulsions where you mix with water. So those ester-based coolants also have similar additives, but of different sources to emulsify the oil and provide the other performance and things like that that are necessary. And then the big difference now is the full synthetics. There's no oil, there's no ester oil, there's no mineral oil in them. It's called a polyglycol type of synthetic oil. We'll get into that next slide. That's the lubricant additive. Some synthetics don't even have any lubricant. They're really there to just flush chips, provide rust protection, and a grinding fluid, for example. These products have a lot of water. All the ingredients dissolve into the water phase. So in a brief nutshell, that's the different technologies and classifications that are on the market. And you can imagine with all these different ingredient combinations, you're looking at hundreds of different products on the market from all different companies. I mean, we alone have over 100 different water-soluble coolants on the market. So you can imagine all the competitors out there, how difficult it is to choose one, for your shop. But there's quite a bit of differences in each formula. Synthetics has become a hot topic lately, especially for us, in part with Titans of CNC, and you probably know him, have seen him. He really likes the synthetic product we offer. It's clear and colorless, and one reason because of that is the use of polyglycol. Polyglycols are fully soluble in water, so they dissolve right in. They provide a very good amount of lubrication. They are fully polar. I'll get more into what the benefits of that are in a moment, but water is also a polar molecule, and that is why polyglycols will dissolve right into water. Like dissolves like. So mineral oil is completely non-polar, water is completely polar, mineral oil will not mix in with the water. You need an emulsifier. Ester oils only have partial polarity to them, so they offer a good lubrication from that polar area, but they do not fully dissolve into water. You need still some help to emulsify them. This next slide is about the lubrication additives that go into cutting fluid. It's a bit busy here, apologize for that, but we'll start with the right-hand side graph. This graph shows lubricity versus temperature. And you can see that mineral oil here provides a decent amount of lubricity, but however, as the heat increases in the cutting zone, the lubricant film fails and the lubricity starts tailing off and you have too much wear. So the metalworking fluid formulator, companies like Blaser and our competitors, are picking additives to mix in with your base oil to improve its performance. We have extreme pressure additives, EP additives, which but in and by themselves provide some good lubricity, but they really kick in at the higher temperatures at which those additives react and really lower this friction. At lower temperatures, an even better lubricant is a polar additive, like I mentioned in the prior slide. Ester oils, polyglycols, they have a very good amount of lubrication. It takes a lot more heat for those to start falling off. But it's a combination really, when you add all these lubricant additives together, along with some other ingredients in the metalworking fluid, the combination really gives you a good synergistic effect in increasing the overall lubrication properties of the cutting fluid. So technically here, extreme pressure additives, these are one of three chemicals: a chlorinated additive, a sulfurized additive, or a phosphorized, or it could be a combination additive that's more than one of those three elements. So customers that want sulfur-free, chlorine-free, phosphor-free cutting fluids, it's more challenging now to come up with a formulation that's going to give you the same type of performance. That being said, the polar additives are very, very good. We've come a long way in developing products that can perform sometimes even better than the products with EP additives. So it really depends also on the application. But those polar additives are ester oils and typically derived from plants. At least in our products, we use plant-based oils or plant-derived oils originally. Metallic soaps, calcium soaps, things like that. And again, these can replace EP additives. And the reason why polar additives are such a good lubricant is because the polarity of those chemicals gives it a strong affinity to the workpiece because they line up like magnets. So the polar end has a charge to it, and all those charges will line up next to each other. And when that lubricant film is on the material, it's very strong comparative to a mineral oil, which is more random. There's no polarity to the molecules of mineral oil. Therefore, their strength is rather weak when it comes to film strength. So that's really the benefit of the polar lubricant. And you want to deliver that lubricant where the higher friction zones occur, between the chip and the tool primarily, a little bit there on the workpiece and tool side. So if you can deliver cutting fluid and lubricant to those two areas under high pressure, you're really going to extend your tool life and enable yourself to make the part much faster. So that's really it on the very basics. We're going to move now into more condition monitoring, what you can do to ensure good performance. You're paying all that money to buy a drum of product with these ingredients that were carefully selected by the R&D team and tested out over many trials and tribulations. And a lot of work was done to give you a perfect product to use. Now let's make it work correctly with the proper monitoring, and we'll get into that now. It starts really with the concentration. If a shop doesn't have a refractometer, I mean, at today's day and age, you can buy one, a cheap one, for probably under $100. So you're looking at, a couple $100 to invest in a very simple tool to give you very quick, accurate measurement of the concentration. It's the #1 success factor in metalworking fluid management, and it's easy to use. We also highly recommend a daily concentration log, where the operator, when he starts a shift, can just check the refractometer concentration and put it on the chart, and you can it'll be graphed automatically over time. These can be customized to put the minimum target concentration for a particular machine and the max. You may have some machines you're running a very difficult job. You might want to run a higher concentration based on the cutting parameters and everything else, or another job you may want to run at a low concentration. So you can very easily communicate to the operator where the concentration needs to be, and that can be logged every day. Too many cases you go in, the customer is complaining, let's say the tool life dropped across the board in the shop, and you go in and you check all the concentrations are all at 1%. Well, no one thought to check the concentration when they started the shift. Meanwhile, maintenance department, let's say, recharged all the machines over the weekend, and they had the mixer set at the top off percentage. So everyone got filled at 1%. This actually happened. Customer doing very difficult work, all high temp alloys a number of years ago. I'll never forget is that we had an order of 25 refractometers after that happened, and an apology from the customer. So these simple things can be done in your shops to really make a big difference. Just simple concentration measurement and logging. Using them also simple. Calibrating, people don't realize these should be calibrated regularly. They can get off, and you can be reading 3, 4, 5% too high or too low. You just simply put some water on here, preferably DI water, and use the adjustment screw on the back of the refractometer and dial it back to 0% with water. And it's a very simple calibration process. The other thing you can use the refractometer for is a condition check. When the coolant is nice and stable and clean, it has very sharp, distinct reading, as shown in the lower left here. Very easy to read the concentration here, very sharp. If the fluid is contaminated or otherwise in bad condition, it may look very fuzzy and difficult to read. And that's another indication that something should be done to fix the fluid to get it in better operating condition. Especially if you're going to be doing some tool-like trials. You have a tooling vendor come in, showed you really nice cutting tool potential, and you put it in a machine that has questionable coolant. Not a good idea. You really want to do all your baseline checking, cutting tool comparisons based on good condition coolant. And a very simple method to check condition is with that refractometer as one tool to do it. Another thing to note is every fluid in the market has a specific range of concentration that was designed to be used in. Some have a wide range, let's say from 3 to 20%. Others have a tight range. And there's a reason for it. If it's below that range, bad things could happen to your machine. And it's above that range, it may be more aggressive to the people and some other things. We'll get into that in another slide. But to measure that concentration is also unique to each product. It's not simply putting on the refractometer and checking it, whatever it is, it is. Each product has a factor. And that's because, in part, due to the water content in the drum and some other ingredients that actually don't read one-to-one on the refractometer. So typically, high oil containing fluids like soluble oils will have a 1.0 factor. It's very simple. Whatever is on the refractometer is the actual concentration. But today, more and more customers are using semi-synthetics and full synthetics with a higher water contents in those drums and other ingredients that affect the factor. And you're looking at factors 1.2 to 2.5 or even higher than that. So when you read that refractometer, if it says 10, you might actually get over 20% of actual product in the machine. Something to be aware of. And that'll be stated typically on the data sheet for the product. In this case, it's a mineral oil containing product, 25%, and the factor of this particular formulation was a 1.4. So if you read, 10 in the refractometer, you're actually at 14%. So what are the risks then of being out of tolerance? So we want to be in that range. That's a sweet spot. But if you're too high, you might see smoke, especially for oil containing products. You're not going to get the cooling ability, and the coolant can start smoking, in fact. You will increase your risk of having people with dermatitis issues. That also depends on the formulation, but certainly the more of it that's in there, you increase your risk of rashes or other health complaints. Residues on the machines, increase in foaming, which can cause a number of problems, especially productivity issues. You're shutting down the machine due to foam. Products also become unstable if they're too high in concentration. They no longer can mix with water. They become oversaturated, or they may flip and become like butter, mayonnaise type of effect with oil-containing products if there's too much. We don't really have time today to discuss exactly how that happens, but be careful about overconcentration. Some fluids can run well above their maximum without becoming unstable, but you do run the other risks that are noted. And of course, if you're running below the target, foul smells, biodegradation, complete tool failure, scrapping parts, rust on the machines and parts, fungal growth. So keeping a log of your concentration is also very helpful to ensure that it's been good for a long time, because operator may have it run at 2 or 3% for weeks and have all kinds of problems with the machine. And then he raises it up to 8, 10%, and you call the Blaser guy in or your coolant vendor in, you come in there, oh yeah, the coolant's at 10% and the machine's all rusted. Well, what was it last week? What was the week before? So it's important to have a log on there to keep everybody up and up, especially your operators, every day thinking about concentration to make sure you get good tool life and good rust protection on the machine. during its use. pH. Couldn't go in the seminar without talking about pH. pH is a health check of your coolant. So for those using water miscible coolants, if you're not checking the pH, you're really not checking the health of the coolant. The concentration will tell you how much is there. If it's fuzzy or not will give you some indication of the condition, but the true health of the coolant, really you need to check the pH. And it's just a measurement of the acidity or the alkalinity of the fluid. All aqueous fluids have a pH. Anything water-based has a pH to it. Many of you have, if you have a pool, you probably checked it before. It's like when you go to the doctor, you know, they take your temperature and they take your pulse and they take your blood pressure every time you go, regardless of your complaint, when you go see the doctor. Now, with the coolant, the pH is something you should check, even if there's no symptoms that are bad. You should just check it to ensure everything health-wise is okay. Or if it's starting to get a little bit to the, let's say, caution area, then it's time to do something about it before there's a problem. And here again, each product has its own specific pH range. You need to consult with the data sheet. And here again, you can add to your daily log of coolant concentration on the top. On below, we would recommend using the same type of chart for the pH. And we have these charts for our customers. What influences pH? Well, number one is the coolant concentration. So if your concentration is too low, you're going to lose your pH. So that is number one factor on maintaining a good pH is also the concentration. But there's plenty of other influencers. Tramp oils that get in there typically lower the pH. Dead zones where you have no air, aeration into the cutting fluid, you're creating an anaerobic environment, and that eventually will cause acids being produced by anaerobic bacteria that are lowering the pH. Cast iron machining creates acids, lowering the pH. Magnesium, interestingly, raises pH. So there's special products specific to magnesium. There's other metals and stuff that decrease it. You know, food sources in the shop, never a good idea. Tobacco, these type things will just kill your pH. Now, the higher you run the concentration of the cutting fluid, the stronger it will be. The buffer will really prevent the pH from dropping. So to be on the safe side, you know you're going to get contamination in the sump. So to be on the safe side, you should run a concentration a few points higher than its really minimum level. So the consequences now of pH, if it's too high, that will lead or can lead to staining of aluminum parts, more foam in the machines, or maybe being aggressive to the people or the machines, it seals, paint, things like that. There's other things that could happen, but those are probably the three most important issues to know about. The pH is too low, which is more common now when the coolant is not maintained well. Then you develop the foul smells, splitting out of the fluid, rust of your invested machine or parts that you've produced, and biological overgrowth. Those are the consequences of not having the correct pH. So we'll get into contamination now. We'll start with the controllable contamination. These are things that we know are going to get into the cutting fluid, but they can be controlled with good fluid management, filtration, housekeeping, just good coolant practices. So the number one, you're going to get tramp oil in there. You're going to get whey lube, hydraulics, spindle oil, greases, all the machine lubes, maybe some process oils that come in from the parts. These are all going to get in your cutting fluid, but they can be controlled by either fixing leaks in the hydraulic systems, implementing skimmers or other removal systems to remove those things. Metal chips and fine swarf, scale, these will all contribute to the dirt load, will build up on the bottom of your sump and create the bad smells, or just become into the cutting fluid and really degrade on the cutting performance. Of course, that can be controlled with investment in filtration, and also on inductor nozzles and other things like that to keep your sump clean all the time. This costs money. Microbial contamination, that comes in from your water, the air, the parts of people, mist collection systems. There's microbes constantly entering the cutting fluid. Can be controlled, look at the mist collection system. Is that draining back into the cutting fluid or draining into a drum for waste? Are people using good hygiene, or are they spitting into the cutting fluid? Things like that. So you can inform the people and do your best you can to control the microbial intake in the cutting fluid. Biofilms, these are things that the bacteria and fungus, hopefully not fungus, but bacteria are going to get in there. They may create some biofilm. That can also be controlled by good fluid management, housekeeping, cleaning the sumps once a year with the proper methods. But if you go year after year and you don't clean the machine, you're going to end up with that picture on the upper right potentially. So that can be avoided with just good housekeeping and better fluid management. But if it starts growing, it's really a problem. It really will kill your coolant and create a bad smell. We talked before about the dead zones. Last but not least here on the controllable are the water salts. We're talking about water hardness, chloride and sulfate. These things will build up. You can see from the picture here in the middle, these salts are in the water. Water evaporates away, but the salts do not, they stay. So every time you add more coolant and more water to the machine in the form of mixed coolant, you're bringing in more and more of these salts. These salts can really cause problems on the cutting fluid, depending on the type of fluid and if it's designed to work with these salts or not. But chloride, for example, really causes a lot of rust on cast iron or pitting, even aluminum, especially the 7000 series aluminum is very susceptible to chloride. Sulfates can lead to bad smells and rust. Hardness will cause separation of the cutting fluid, residues, things like this. So in many cases, DI or R of water is really necessary to control those salts. The avoidable contamination, this is really more of a people management thing. That's preventing the tobacco products, food and beverage, bodily fluids, mop water, farmers' boots. You guys come to work and they work on the farm early in the morning and they come later in the day wearing the same boots. Well, if they're working on machines that have big machines and they're walking on the machine and whatever's in the bottom of their boots is now flushed into the coolant system, this can be a big challenge for the cutting fluid. So something to think about. And those of you who are in the farming areas. Cleaners and WD-40. Operators tend to love WD-40, or setup people do. It is a killer for coolants. It really separates most coolants out very easily. So keep the WD-40 out, keep those cleaners out. Use the cutting fluid to clean the machine if you can. So those are all avoidable contaminants. Tramp oil is probably the biggest contaminant that people think about, in addition to the metal fines and swarf. So keeping that out is very important, especially machines that use a lot of whey lube. Key ingredients of the cutting fluid itself are absorbed into that oil and lost. In addition, those tramp oils leach out undesirable chemicals into the coolant that create negative effects. Primarily smell is what you notice, but there's other issues going on as well. For example, sulfur additives come out into the cutting fluid, and some customers have sulfur-free requirements. Well, you should ensure your whey lube and hydraulic oils are also sulfur-free if that's your requirement. There are food sources for the undesirable microbes that create the bad smells. They definitely affect the tool life, can go dramatically down with just even a small amount of emulsified tramp oil. So it's really important to remove that tramp oil when it gets in, especially machines that use a lot. Put a practice in place to take it off, sooner than later. The longer it stays in the sump, the more likely it is to be beaten in, to be emulsified, and really start killing your tool performance and generating smoke and increasing the mist in the shop. Not to mention it's shortening the sump life and increasing your disposal costs, creating residues on the machine, and so on and so forth. On neat oils, just a note, once the tramp oil gets into a cutting oil, you can't take it out. These things don't separate, they just become a permanent part of the cutting oil. So it's a matter of just controlling the amount that gets in. Of course, you're going to lose cutting oil every day on the chips and put fresh in, so you hope that the amount of tramp oil doesn't get too high where it doesn't have a big negative effect on your performance, but it will affect the viscosity and dilute down the additives, not to mention potential health and safety aspects of some of those oils getting in to your cutting or grinding oils. Another note here is the effect of these oils is dependent on the type and brand of whey or hydraulic oil in combination with the specific metalworking fluid. So a combination of XYZ whey lube with XYZ coolant may be okay, but maybe not okay for the next coolant. So, and it really varies a lot. So if you have machines that do leak a lot, it's important to have that checked. Machines that don't leak a lot, that's really less important to check the unique or specific effects of those combinations. But machines that leak a lot of oil, especially on a machine that's a critical process to you, you need to make sure that the combination is okay. Dirt load. Here you have, damage, not just the coolant, but the machine itself. You have wear on your pumps, on your seals, your valves, and other things like this on the machine can really be damaged excessively and cause you excessive maintenance costs, not to mention all the negative effects on the cutting fluid. The longer that swarf sits in the fluid, the more metals leach out of it, form lead soaps, for example, or you have copper leaching, cobalt leaching when it comes to grinding carbide, for example. You have chrome or nickel, those are allergens that people may have skin rashes from. There's a host of things that happen you can avoid or at least limit if you can keep the sump clean, keep the coolant clean and filtered. That'll help also give you consistent tool life and longer tool life. So a lot of issues here, and the filtration people will be glad to come in and talk to you about all the benefits of filtration. And the amount of that investment really depends on just how critical your process is, right? So lower left, you're looking at millions, $1 million plus investment in filtration. Maybe on the right, not so much of an investment in comparison, but you have to make this decision for yourself, just how important your process is to keep it running 24/7 if you needed to, what you would need to do filtration-wise to achieve high performance of your cutting fluid over time. Stability, stability, stability. I say it 3 times because it's entrenched in us when we start at Blaser how important stability is, and that there are 3 basic categories of stability. You have the physical stability of the product, chemical stability, and the biological. So from physical, we're talking about emulsion, oil and water. Oil doesn't really mix with water, right? It forms an emulsion, a droplet, dispersed in the water. So physically, that needs to stay in suspension and not separate. From a chemical point of view, we need to make sure the pH is stable and not dropping, as per the reasons we discussed, explained earlier. Also oxidation, that's also part of the chemical stability. You want to make sure these fluids don't oxidize and degrade, really lose their performance. They start forming residues and odors and things like that. That's especially important for neat cutting oils, that they resist oxidation, but of course with the water miscible fluids as well. And last but not least, the biological stability. You do not want an overgrowth of bacteria that's degrading your cutting fluid, or where you have systems growing fungus. This is a disaster, not only for the cutting fluid and the performance, but from a health and safety aspect as well. So it's really important to choose stable metalworking fluids and then maintain, monitor and maintain those to keep a stable process altogether. So a little bit more on the droplet size here. We're looking at oil and water emulsions. Oil, again, doesn't dissolve into water. It forms a droplet. And that's due to the emulsifiers used in the metalworking fluid formulation. So the amount of emulsifier, the type of emulsifier, in combination with the type of oil, and the amount of oil that's in the formulation. So the idea is to create very small droplets. And the reason why is there's a repulsion force created by the emulsifier. And that keeps those droplets separated. Oil is lighter than water. They want to come to the surface. So to keep them separated and keep them dispersed and preventing them from coming to the surface, they need to be small with a strong repulsion force. If they start becoming larger, they're going to coalesce together and become like comparatively like a big beach ball, and they're trying to push it down into a pool water. It's going to come to the top. Okay, so it's going to be hard to have a stable fluid if those droplets become large. They can become large due to tramp oil effects, salting up from too much hardness, for example, and a host of other things can cause a failure in that regard. So it's really important that the emulsion droplets stay small. And one way to check that is with that refractometer. It gives you that really sharp reading that was shown earlier in the slides. Nice and sharp also means you have a small droplet size. When those droplets get larger, that's when that fuzziness begins on the refractometer. And that's where you really start losing some of those characteristics that you want. The cleanability of the product, how nice it runs on the machine, and the usage, consumption stays low as well. When those droplets run right back into the sump, those large droplets will get carried out on the chips, and all of a sudden your consumption can go really high. So those are things to think about on stability. So now we'll move on. Hopefully that was good for you as far as understanding the basics of fluids and how to monitor them and take care of them. Now we'll get into more some special application here of high pressure. Most of you probably have used high pressure or have multiple machines running high pressure, but what does that really mean? So technically anything over 300 PSI is considered high pressure. But the reality is you need to be 1,000 PSI to get the real big benefits of high pressure. Sometimes up to 1,800 PSI for water miscible coolants, in rare cases even higher than that. For neat oils, looking at 2,000 PSI, pretty much being the max offered by most of the pump suppliers, although 3,000 PSI is also available in certain applications by some of the manufacturers who supply these high pressure systems. So what it does really is prevents the long stringy chips. It breaks the chip during the cut. So it'll really prevent the friction, really reduce the friction, and prevent the long stringy chips from screwing up the process, giving you a very stable process here and allowing you to cut a lot faster. Often it is at least 20% increase, if not a lot more than that. So it's really necessary, in my opinion, if you really want to be ahead of the competitors and staying competitive, to employ high pressure coolant systems. Things to consider though are foaming. They will generate a lot more potential for foam, so you need to select a metalworking fluid that's suited for high pressure. It can be where you use a product that's not really suited for the high pressure, but you can get it to work because you may only be using high pressure on a small percentage of the cycle time. Or the sump may be very large, not a lot of turnover, plenty of time for the foam to dissipate and go away by the time the coolant's pumped again. So the foam kind of is also dependent on how you use the high pressure. Certainly for machines that are going to have high pressure at 50% or more of the cycle time, you need to use a product that's designed for high pressure. And for neat oils, also under high pressure, use a little bit lower viscosity, maybe 22 max viscosity, 10, 15. Those are viscosities better suited for high pressure because you want to release the air out of it. Using a 32, 42.8 oil for high pressure, often the pump manufacturer will tell you that's not going to work anyway. So typically 22 or lower viscosity used for high pressure. And the lower the viscosity, typically the faster air release, although we do have some specialized oils that we offer with very, very fast air release, especially for smaller sumps where you have high pressure and a lot of pumping going on. You want to make sure the air is completely released before you pump again. And air is not providing any lubrication. It can really screw up the process if you have too much entrained air in the neat oil. Another thing, of course, is mist. If you're putting the coolant under that much pressure, you're going to generate more mist. You need to invest in a mist collection. You're going to deliver high pressure coolant through the spindle. You need to filter that fluid, looking at typically 5 micron filtration investment. And also just throwing high pressure on the machine isn't going to give you that much benefit unless you have the right tools, special tool holders and collets, and using through the spindle, through the tool, cutting tools. As pictured here, a special turning tool with channels that go on both sides of the insert for maximum productivity. So your tooling suppliers can help you with those things. Here's an example of high pressure put to use in our tech center, a 25 times deep gun drilling application of 4140 heat treated steel. So we're starting off here with some pilot holes, and then we're going to go show you the results of a deep hole drill under high pressure. So 200 millimeter depth hole, 8 millimeter diameter. That's 25 times 10 seconds. So I don't think that can be done without high pressure and a high quality, cutting fluid. So just a nice little example here of what high pressure can do for you. If you have the right tools, the right machine, the right holder, and all these things are necessary to make it work. So that's really what we're talking about when the coolant becomes a liquid tool. It's putting it all together here. The right cutting tools, the right machinery, the right operation, the right cutting fluid, getting the most out of everything with the high pressure. So we have another case study to show you when a coolant becomes a liquid tool. And just this slide to start with here, looking at the cost of your cutting fluid, just the raw cost of concentrate is really only 0.5% of your overall cost of making that part, or the production cost. And this is based on a third party. We didn't do the study, another company did it in France. But the average true cost of the cutting fluid is only 0.5% of the overall production cost. So when you're shopping out there for metalworking fluid and you're focused on how much that drum costs, you're really looking at the right thing versus what effect that cutting fluid has on your overall manufacturing process. If we can cut your cycle time down or improve that tool life or protect that machine from rust or keep your people on your machine rather than at the doctor seat for dermatitis issues, that all those things can be greatly affected by the metalworking fluid. Huge effect, a huge amount of cost can be improved, or in the other side, cost you a lot of money with just a small amount of investment in the metalworking fluid. So it really has a big leverage effect. A small amount of money spent on cutting fluid can have a huge leverage effect on the amount of money spent on making that part. So please keep that in mind when you're looking at your metalworking fluid and the cost. Look at the overall cost that it actually affects. The cutting fluid touches everyone that walks out in the shop because you're exposed to the mist. Every piece of the machinery that you bought, those big investments you made, are covered now in the cutting fluid. The cutting tools, the beautiful parts you've produced, all these things are touched by the metalworking fluid. And a lot of time was spent by companies like Blaser and maybe some of our competitors who have a decent R&D. Spend a lot of time formulating these products. We also spend a lot of time trying to educate our sales force and then our customers to make sure they get the most benefits from this small investment in cutting fluids. So that's a little preamble now to the when a coolant becomes a liquid tool. This is now going to show you an example of changing the lubricant. So it's one thing when you change a bunch of factors, employ high pressure and use a water-based coolant, we have cooling effect, but just showing you now what difference of changing only lubricant makes. And one example of that is using MQL. So minimal quantity lubrication. We're not worried about flushing chips here with the cutting fluid. We're not worrying about cooling. We're just lubricating. So we bought actually a Grove machine. You can see here in our tech center, And we've done a lot of work optimizing the MQL process using different MQL oils. And so our R&D people specific on the oil side, working hand in hand with our tech center, optimizing our MQL, minimal quantity lubrication oils. The next video I have to show you will show you the difference between using one MQL and then running the same tool with a different MQL oil. And it's milling aluminum here with a Lubricity system using a Fraser tool. We start off by looking at the cutting data recommended by Fraser. So for this particular tool, on the top you can see the tool running as per recommendation of the tool supplier. The bottom, we increase the metal removal rate by a factor of 3 with our MQL oil. So you can see much faster results with our oil. So now we upgraded with the previous oil, product X, we did the same increase by a factor of 3, the metal removal rate, as we did with ours below. And reran that tool, a new tool under those conditions. And you can see here with the thermal camera, I mean, it stalled halfway through the part and then the tool broke. So under those conditions, that oil did not provide adequate lubrication. And here with ours, we continue running more and more runs through this part here. In fact, we did over 10 more runs and still had not broken that tool. So dramatic improvement, a factor of 3 metal removal rate, and we can make over 10 passes. So great results, just changing the oil. And we know in proving that was, running the previous oil at the new cutting conditions, it didn't work. So it does make a huge difference in selecting the right cutting oil. And we can help you with that with our people in our tech center and our engineers can look at your process and we can optimize the process for you, whether it's an MQL or a flood application or a neat oil application. We have that offered to you. So my message to you is be cool with your tools. Increase your competitiveness, take care of your cutting fluid, it'll take care of your tools. And only the right cutting fluid managed properly really makes it a liquid tool, and that'll boost your productivity, and that's what we're here to do. And with that, I leave it for questions and answers and discussion. We have another 7 minutes.
For those who have questions, I think you can type them in the chat area. And if you have some, we can review them now. No.
Looks like there's a question about full synthetic. I don't see the total question. Okay, if there's no questions, I thank you all for your attending and listening in today. Hopefully you got something out of it in this short.
Hey, Randy.
Sure.
Randy, it's Linda, the staff liaison for the tech team. You do have a couple questions in the question box.
Okay.
There are several popping up, so I just wanted to alert you so you could get to that first one.
I see a question here. Are you seeing more to large production facilities or smaller shops? I don't see the first part of the question. Could someone, or maybe Drew, can you see
Sure.
it? I can't see the whole question.
I can read it. I can read it for you.
Thank you.
The first question was from Kevin. He wants to know, what is better, DI or RO? We switched to RO when we went to full synthetic.
Good question. When it comes to the quality needed for metalworking fluids, DI water and RO water provide good enough quality that's required. Some customers who have really bad water will have an RO system, and then they'll take the RO water and put it through a DI tank, just to be sure, because their water is so poor. But most customers, you can either use either one, RO or DI, and have really good results with your cutting fluid. Just make sure it's monitored and make sure the water quality is consistent.
And Randy, just to add to that, with a synthetic fluid, it's much better, I think, to use an RO or DI water system, because you don't get the buildup of salts or the buildup of hardness materials that can cause like white scaling and things, and maybe even some stability problems with the fluid. Would you agree?
Yeah, I mean, hard water can cause a problem for all different types of cutting fluids, whether it's a full synthetic or not. Full synthetics are more prone to sticky residues when water hardness accumulates too high. A lot of synthetic fluids also may have rusting issues quicker than a non-synthetic if the chlorides are too high. So it's very important that your chloride levels remain low by using RO or DI water. You're not using any oil in the products, you're only using the water-based corrosion protection, which can be very, very effective. However, if there's too much chloride in the fluid, you're not going to have good results. So that's why synthetics do better with RO water and DI water overall. There are some formulas of full synthetic that we offer as well that don't require the use of DI or RO water. So it really depends also on the formulation itself and the specific product. But good question, we get that one a lot, as far as the DI or RO water.
Kelly, are there other questions?
The second question is from Doug.
Linda, rather, sorry.
Yeah, that's okay. Do you have these technical capabilities in regard to MQL in the US?
We do not have a person with extreme high knowledge in the US of MQL, and our machine and tech center is in Switzerland, but we have dedicated people who focus on MQL projects for anyone around the globe. So we can organize, meetings via Skype or other methods like that to discuss the application with you. Our applications engineers in the US are very, very familiar with MQL. They have some basic training, but the advanced stuff that's done to optimize the process is done with our MQL experts in Switzerland.
But to add to that, we have brought those people over for certain projects at certain companies when they required assistance in the original setup.
We were flying into the US as needed. Yeah.
There's also another question with regard to MQL. What is driving MQL? Is it environmental or cost?
Everything really. With MQL, you eliminate the use of water, a resource, natural resource. You eliminate the cost of installing your coolant system, energy costs to pump the coolant around, the fluid management systems, all of those costs going around cutting fluids, especially water miscible fluids, you avoid if you can get the MQL system to work. And normally you have to buy special machines that are designed to run MQL, because you don't have the coolant now to flush your chips. So you're using different technology to remove the chips from the work area. But certainly it's environmental and also a cost issue. There are performance benefits. We've seen some applications where MQL can actually provide the best cycle time versus a flood coolant. So there are certain applications where it's actually a better performer. But they've come a long way when it comes to MQL technology through the spindle, how it's delivered, even now at high pressure. Some companies have high pressure MQL systems. So the system deliveries technology has changed for the better. The cutting tools themselves and the holders, all those things have improved dramatically over the years. And of course, the MQL oils, we've done a lot of work to improve that. So the whole process of MQL is very, very, very interesting, especially for, let's say, a high production setup where you run the same process over and over. We see that more and more in the automotive sector, for example, moving to MQL, for example, at Ford.
Hey, Randy, I have a couple of comments from Dean for you and then also a question. So let me start with the comments. He would like to know, or like you to know, that you did a great job. Are you in Phoenix? He's also in from Modern Industries and would like to invite you down if available. And his question, are you seeing more in large production facilities or smaller shops?
Well, I do live in Mesa, so I'd be glad to come over and say hello. I guess, what was the question about large productions or shops or small? I'm not sure what, you talking about Blaser specifically, or?
I'll read it as he wrote it. Are you seeing more to large production facilities or smaller shops?
Maybe as opposed pertaining to MQL, possibly.
Maybe it's regarding MQL, it's certainly more geared towards high production. That being said, some smaller shops are finding they can apply some of the lower cost MQL systems, especially for getting away from dry milling. With MQL versus dry milling, it's a huge benefit in the tool life and cycle time reduction. So to spend the $40,000 even makes sense for some smaller shops if they do a ton of dry milling. So I think the trend is even coming some more, even with some smaller shops, to apply MQL devices there as well.
Randy, I had a quick question. Did we get permission to use Gisbert's picture in that one slide that you showed?
Whose picture?
Gisbert. He's on the tech committee too, so I saw him in one of the slides. So.
Oh, I didn't realize it was in that picture. I just added that picture today, and I didn't realize he was in it. So, yeah, we'll have to ask Gisbert. Okay.
Linda, any other questions?
I believe that is it for the questions as of right now.
Okay, well, on behalf of the NTMA Tech Committee, I'd really like to thank you today, Randy, for an excellent presentation. I think it gives a very well-rounded look at how NTMA members can improve some of their metalworking fluid practices, whether they use Blaser or not. And we don't want this to be a Blaser commercial. These are practices that are really universal for coolants. And feel free, though, if you ever wish to contact us, we can always act as your consultant, even if there is not a commercial value in it for us. If we can help you out, we're, as always with the MTMA, we're more than willing to do that. So with that, Randy, a real thanks for you and a great presentation.
My pleasure. Thank you for having me.
Thank you, Randy.
And thanks to all the audience for participating. We appreciate that.